Welcome back to Science Modernizers. Welcome back to this video. We are going to see in this video curve sketching for maths with mechanics students and maths with statistics students. So stay tuned as we proceed with the video, and if you are not yet subscribed to our channel, please subscribe to get more of such videos. Now we have the function f of x is equal to 2x plus 1 divided by x minus 4, and we want to sketch this function. So what do we do? Now, in order for us to sketch a function, I'm going to give some brief steps which we are going to follow. The first thing is to know where the function lives, and we call that the domain of the function. The next, we are going to verify intercepts, and also we are going to calculate the asymptotes. Now from there, we study the variation, that's the monotonicity, then we can sketch. So we are just going to use these brief steps in order for us to do this. This is not like curves in further mathematics, which entails more details like points of inflection, etc. Now for this curve, we have y is equal to 2x plus 1. So the first thing that we do is to find the domain of the function f. So what's the domain? The domain is simply the set of values for which the set of values of x for which this function is defined. And so this function will be defined for every value of x except when the denominator is equal to 0. So it means our domain df will be such that x will belong to the set of real numbers in such a way that our x minus 4 should not be equal to 0, and so this will mean that x should not be equal to 4. So definitely the domain of a function will be x will belong to the set of real numbers such that x should not be equal to 4. Now, can we write this in interval notation? Possible. So the interval notation r starts from negative infinity, then we are excluding a point 4 from above and below, then positive infinity. So that's the domain in interval notation. Either you leave it like this or like this, no problem. So that's how we find the domain of a function. Now the next thing, let's find the intercept. Let's find the intercept. Okay. Now for the intercepts are simply the points where the graph cuts the ordinate axis, be it the y-axis or the x-axis. So let's begin with the y-intercept. When does the y-intercept occur? The y-intercept occurs when x is equal to 0. Now I'm going to let y to be f of x. I'm going to let y to be f of x. But our f of x is 2x plus 1 divided by x minus 4. F of x, so it means my y will be equal to 2x plus 1 divided by x minus 4. So what does it mean? When x is 0, y will simply be equal to 2 times 0 plus 1 divided by 0 minus 4. And this will give negative 1 quarter. So one of our intercepts, that's the y-intercept, will occur when x is equal to 0, y is negative 1 quarter. Now we calculate the x-intercept, where is going to cut the x-axis, the x-intercept. So the x-intercept occurs when y is equal to 0. So when y is 0, we have 2x plus 1 divided by x minus 4 is equal to 0. And this is true if and only if 2x plus 1 is equal to 0. And that's true if only if x is equal to negative a half. So what do we have as x-intercept will be negative a half 0. So we keep that. Now the next we have our asymptotes. So here we are going to deal with the two asymptotes common in maths mechanics and maths with statistics, not further maths. Here we don't deal with oblique asymptotes here. So at this level, what is a vertical asymptote? Now you have to know that the formal definition of a vertical asymptote is if you have a certain point and that the limit as x approaches a of that point at the given function f of x, if this gives you plus or minus infinity, then x is equal to a is a vertical asymptote. But this can simply be obtained in simple terms by equating the denominator to 0. That's how we get that. So what's the denominator here? X minus 4. So we have the VA will occur when x minus 4 is equal to 0, and this is true if only if x is equal to 4. So hence the line x is equal to 4 is a vertical asymptote. Now let's see the horizontal asymptote. The horizontal asymptote is obtained by evaluating the limit as x approaches infinity of the function f of x, and this will be the limit as x approaches infinity of the function 2x plus 1 divided by x minus 4. Now to evaluate this, we divide top and bottom by the highest degree of x. So we have is equal to the limit as x approaches infinity of the highest degree of x is x, so there will be 2x on x minus 1 on x divided by x on x minus 4 on x. So this will be equal to the limit as x approaches infinity of 2 minus 1 on x divided by 1 minus 4 on x. Now what do we see? Now we notice that as x becomes so large, 1 on x becomes so small. So it means 1 on x will turn to 0, 4 on x will turn to 0, so we'll be left with 2 on 1, which is equal to 2. So therefore y is equal to 2 is a horizontal asymptote. Now going straight to the point, I'm going to pass through the monotonicity. That's the study of the derivative, the monotonicity. So what do I want to study here? I want to study the sign of, I want to study how f will behave across given intervals, and it suffices for me to study the inequality f prime of x is strictly greater than 0. If I use the equal sign, it means I'm going to take the case when it's equal to 0. Those are turning points. Now does the graph have turning points? We are going to verify that. So let's verify f prime of x. So remember, f of x is 2x plus 1 divided by x minus 4. Now we have a given rational function, so we are going to use the quotient rule to differentiate. So f prime of x will be top constant. Top, we keep 2x plus 1. We differentiate the bottom. The derivative of x is 1. Derivative of minus 4 is 0. Minus, sorry, is bottom constant. Mistake. The bottom is constant. We differentiate the top. When you differentiate 2x, you have 2. Differentiate 1, you have 0. Minus top constant, 2x plus 1. We differentiate the bottom. We have 1. All of this divided by x minus 4. All of that squared. So let's simplify. This means f prime of x will be equal to, we open up our bracket, we will have 2x minus 8 minus 2x minus 1. So this will be equal to divided by x minus 4, all of that squared. So this will be equal to 2x minus 2x will cancel. Negative 8 minus 1 will be negative 9 divided by x minus 4, all of that square. Now the question is, will this always be positive or negative? Now let's see the nature. Now we see that the quantity down, x minus 4 all squared, is always positive for every x that belongs in R. That is what I'm saying is x minus 4 all of that squared is always positive for every x in the set of real numbers, save the case where x is equal to 4. So we don't need this, we don't need that case, because it will not be defined. And so since this is always positive and the numerator is a constant, what does it imply? It means that f prime of x will be negative for every x in the set of real numbers, such that x should not be equal to 4. So that function is a decreasing function since f prime of x is negative. Now what do we do next? We can use the derivative to verify if we have turning point. Now if we set f prime of x is equal to 0, this will mean that we'll have negative 9 divided by x minus 4, all of that square is equal to 0, and this will mean that negative 9 is equal to 0. Impossible. Negative 9 cannot be equal to 0. So what does it imply? No turning point. No turning point. So here we have no turning point. Now if we resolve in solving this inequality f prime of x strictly greater than 0, this is what we have. So I want to get some certain regions. So if we solve the inequality f prime of x strictly greater than 0, it means we will have negative 9 divided by x minus 4, all of that square strictly greater than 0. So for critical values, that of the denominator, we have x minus 4, all of that squared is equal to 0, and that's true if only if x is equal to 4. Now I will represent this critical point on my number line. So we have something like this. The point 4, I will use it wrong since it's not defined. 4. Now you see that if you look below 4, take any value, negative anything, negative 5, even 0, you plug in here, you are always going to have negative because of this. So this region is negative, likewise this region is negative. So as we earlier said, it's a decreasing function, so it will decrease from negative infinity to 4 and will decrease from 4 to positive infinity. Now with this information, we can already be able to plot our curve. Now let's plot the graph. Okay. Okay, so these are okay, so this is our Cartesian plane. Let me reduce the size. These are Cartesian plane. So here we have the y-axis and here we have the x-axis. So we start by representing our asymptotes. So we had an asymptote at the x, that's the vertical asymptote, it was at x equal 4. So we can do this. Asymptotes are represented with broken lines. So your line should be straight. And then the horizontal asymptote occurred when y was 2. So it's something like this. Okay. Now they meet somewhere there, that's the center of symmetry. Now the next, we now have to represent our intercepts. Now let's verify the intercept we had. So our intercept was when x was 0, y was negative 1/4, and when y was 0, x was negative half. So let's represent that on this curve. Okay, now when x was 0, y was let me write the function here, was 2x plus 1. Okay, so when x was 0, y was negative 1/4. So x0, y negative 1/4 is somewhere here. And then when y now was 0, x was negative half. So negative half is somewhere here. Okay, now it means we are going to have our curve will behave like this. From negative infinity is going, and it's gradually decreasing, and we continue decreasing, and we continue decreasing right up to that value. So we'll continue like that, and the same thing will happen here. So we see that from 4 to positive infinity. This is where I look at it. So how do you sketch? You start, this extreme end represents minus infinity, this 4, and that's plus infinity. It's just our domain here actually. So what do? From minus infinity, it is showing that it is decreasing. So what does it mean? Decreasing means you are leaving from a bigger value going to a smaller value. That's actually what it means. Now since I'm decreasing, it means I'm moving from a bigger value and I'm gradually descending, a bigger y value, and I'm gradually descending to smaller values, but noting that I have to cut the ordinate axis at some point. Here we have, when x is 0, this negative 1/4 and this negative half. So those are intercepts where it cuts. Now you see now that from 4 to positive infinity, this is an asymptote, so it is not defined on that line. What do you say? It is decreasing, so it means it is leaving a big y value, gradually going down, but it meets an asymptote and it will never touch that asymptote, so we'll continue like this. So that is the shape of a graph y is equal to f of x. So the variation, or let's say this number line, permits you to draw your graph and it gives you the shape. Now let us picture this on GeoGebra and see what we have. Okay, I'm going to impute the function. What's the function? I think the function was 2x plus 1. So I'll put these things in bracket. Then I'll put divided by x minus 4. I believe you're already seeing the display of a graph. So that's a display. Let me zoom out. So that's a display. So that's exactly what happens. That's exactly what happens. So you see this point. These are the intercepts. Those are the intercepts. Okay. So that's basically the curve. I even think I omitted something. Let's see. Oh, sorry. My negative 1/4 and my negative half are wrongly placed. Sorry about that. Okay. Sorry about that aspect. Let's correct. Intercepts are x is negative half, y is 0. Okay, negative half. Let's say our negative half is here, y is 0. That's the point. And the next was when x is 0, y is negative 1/4. Okay, sorry for that error. So you see, as I'm going, it is decreasing, and it has to cut my ordinate axis at this point, and it decreases right down. So sorry for that little error. I mistakenly used the positive axis for that. So as you can see, that's actually the shape of the graph on GeoGebra. So we can know the point where it cuts. The point of intersection, that's here, is actually half. So if I just do something like this, you see, that's the point, negative half, 0. And if I zoom out, I tap it somewhere here, 0, negative 0.25. So those are the intercepts. So if you want to represent your asymptotes, I can say our asymptote was x is equal to 4. You will see that it will not touch. And we had the next y is equal to 2. Okay. Now let's see that. That's what we have. Okay. Now I can remove this point. I can give this some to be broken since it's an asymptote. Then we can give it a beautiful color. Okay, let's say this. Then we take this same, we'll give it a beautiful color, broken lines. The color is making beautiful. So that's the shape of our graph. So you see, that's exactly what we have. We will never touch the asymptote, never. Thank you very much for watching. Do not forget to like, share and subscribe. See you in the next video.